We usually think of space as, well, just out there, right? Distant, empty, not really affecting our day to day. But what if I told you there are these powerful, invisible forces from deep space that are constantly shaping our technology, our planet, and maybe even us? In this explainer, we're going to pull back the curtain on these cosmic currents and see how they have some very real effects right here at home. Okay, so here's a riddle for you. What in the world connects a high-tech piece of gear failing to an animal suddenly losing its way? I mean, they seem totally unrelated, but they actually share a common invisible cause, a cause that starts millions, sometimes billions of miles away. And trust me, we are going to connect those dots. So let's start with the big guy in our sky, the sun. Sure, it gives us light, it gives us warmth, but it also has this much more violent side. Think of it like a fiery breath that can blast all the way across 93 million miles of space to reach us. So what exactly are we talking about here? Okay, picture a bunch of magnetic field lines on the sun's surface getting all tangled up, like a giant cosmic rubber band. And then, suddenly, snap. That snap unleashes a mind-boggling amount of energy. That's a solar flare. And this isn't some slow-motion thing. It's a massive explosion that sends a wave of radiation hurtling toward us at nearly the speed of light. And I love this analogy because it's just so perfect. Imagine the sun lets out a giant sneeze. It's not like something physically hits us, but it's this huge burst of energy. And while our planet is mostly protected, our super delicate technology, it can definitely catch a cold from that sneeze. It's a really simple way to picture a hugely complex event. And that cold can be pretty nasty. We're talking about scrambled radio signals for airplanes and first responders. Your GPS going completely haywire. Satellites can get their circuits totally fried or even get dragged down from their orbit. Yeah, that one little solar sneeze can cause a multi-billion-dollar headache for us down here. So if the sun is sneezing at us, how are we not, completely fried? Well, thankfully, we're not defenseless. Earth has its own built-in protective cloak, a magnetic field. But here's the crazy part. That shield isn't set in stone. It's always moving, always shifting, and sometimes it gets dangerously thin. See, deep below our feet, there's this massive ocean of molten iron just churning away, acting like a giant engine. That's what gives us our magnetic field. But here's the thing. That flow, it's not super steady. And because of that, our magnetic poles are always wandering around. They aren't fixed points on a map. They're constantly on the move. And sometimes they do a lot more than just wander. And this isn't just some wild theory, okay? It has absolutely happened before. If you go back about 41,000 years to an event scientists call the Lachance event, the poles didn't just drift, they completely flipped. What was north became south, and what was south became north. It was temporary, yeah, but it was an incredibly dramatic moment for our planet. And during that massive flip, our planet's protective shield got weak, like dangerously weak. How weak, you ask? It dropped to just 5% of the strength it has today. Can you imagine? It's like trading a heavy-duty winter coat for a thin t-shirt in the middle of a cosmic blizzard. For a while, Earth was just incredibly exposed. This is the absolute best way to think about it. That cosmic wind they're talking about, that's a real thing. It's a constant stream of charged particles shooting out from the sun and from deep space. And normally, our magnetic cloak just deflects it all. But when that cloak thins out, well, a lot more of that harmful radiation can sneak through and reach the surface. So what happens when that shield is weak? Well, for us, our compasses and all our navigation systems could go totally haywire. And hey, remember that lost migrating bird from the beginning? Many animals actually use the magnetic field to find their way. A shift could throw them completely off course. Plus, we'd all be exposed to higher radiation levels, both here on the ground and especially for all those expensive satellites we have up in orbit. Okay, so we've looked at threats from the sun, and we've looked at vulnerabilities from inside our own planet. Now let's zoom way out. Let's look at the invisible magnetic neighborhood that our entire solar system is traveling through. It's like this huge cosmic structure we're all constantly navigating. So as the sun spins, its magnetic field gets twisted out into space like this giant, wavy, spinning skirt. That's the galactic current sheet. It's this immense structure that goes way past the orbit of Pluto, and our little planet Earth has to pass right through the folds of that skirt. I just think this is such a cool way to picture it. It's not a static thing. We are literally surfing through a magnetic tide.
Some parts of the wave are calm and smooth sailing, but other parts are really turbulent. And when we cross from one to the other, it can have real effects on Earth's own defenses.
And get this isn't some rare, once-in-a-lifetime thing. Because the sun rotates, Earth passes from one magnetic section of this sheet to another roughly every 27 days. It's like clockwork. And here's the key takeaway. When we make those crossings, our planetary shield can get temporarily weaker, which makes us even more vulnerable to those solar sneezes we talked about.
All right, so we've got solar sneezes, a wandering planetary cloak, and a cosmic magnetic tide. 3 huge, powerful forces. Now let's bring it all home and connect the cosmic dots to see why any of this really matters.
Okay, let's put it all together. You've got the solar flares, the sun sneezing, which can knock out our tech. You've got the magnetic pole shifts, our thinning cloak, which can mess with navigation and expose us to more radiation. And then we're surfing this galactic current sheet, which can lower our defenses. The important thing to realize is that these forces don't happen in a vacuum. They all interact with each other, creating this complex cosmic weather system that we're living in every single day.
So at the end of the day, this isn't just some cool space trivia for astronomers. This is essential stuff, protecting our power grids, making sure our satellites keep working, trying to predict climate effects, even understanding the history of life on this planet. It all ties back to these massive, invisible forces from space.
And that really leaves us with one final and pretty urgent question. We know the sun is heading into a more active cycle. We know our magnetic field is always changing. So as all this cosmic activity ramps up, are we actually ready for the effects? Are our societies and our technology prepared to handle it? That's something we really need to be thinking about.